So Joe's first question was, where's the fire?
Oh, Fireside Chat, so it'll be fun.
Yeah, we figured the open flame would be slightly dangerous. And then if we had huge flames surrounding us, it would be, from Hades, and it would be change the feel of things.
Yeah, but much more dramatic.
The history
Hello,
would
Robert.
be very dramatic. Well, thank you all for attending. This is very exciting. We got the band together. It's all back together. Here we are. So we have.
Excuse me a minute. Hello, Joe.
Hello, Mike. Hello, Robert.
Hello, Joe.
Hello, Jane. Hello, Garrett. Hello, Bjarne.
Sorry about
Hello,
that.
audience.
That's all right there. Okay, so thank you for attending. We're going to start this off with, I'm going to ask each of you to introduce yourself. So if you could just give us your name and then your role in the development of Erlang. And then answer, please, the following question. Dog person, cat person, or other person? Bjarne's like, so dog person, cat person, or other. And if it's other, it has to be named. You can't just go with other. So we'll start with you, Mike.
Well, to start with, I'm a dog person. In fact, I've got a dog website as well, which I run nowadays. I would advise anyone trying to write a website not to do it in Erlang and not to do it in WordPress. Both of them are equally horrible. Not the Erlang such, but the Erlang websites. But I'm definitely a dog person, and my role basically was that I started the computer science lab at the same time as Bjarne was the person starting it, and my role was basically thinking about what the requirements were, what needed to be done, and then I was the person that thought about the C-wire, which we can talk about the C-wire later.
Oh, yeah, the sea wire.
Oh, yeah.
Joe?
Yeah, I'm a cat person. I got 2 cats. Daisy, the bipolar cat, and he's a very scared cat. And Mike conned me into joining the computer science lab, and Bjarne and Mike gave me some problems to solve. So I started looking at how we could program telephony, and things have kind of blossomed out of control since then, and in a way that was rather unpredictable.
Okay, we'll get into some of that. Bjarne?
Well, Mike and I and 2 other guys started the computer science lab. That is, we went to the CTO of Ericsson and suggested that we should have a computer science lab because there were soldering labs and chemistry labs and all sorts of labs, and we thought most design dealt with programming, so why is there no computer science lab? So we suggested that, yes, we could do it. And we were given permission to it. I think that was in 1980. Ericsson must have had some money to spare or something, or those were generous times or something like that. And in 1984, it became sort of a formal unit, not just 4 or 5 hackers. There are a few others like Per Hedland and others who were along at that time as well. And I think I might be a sort of, I don't know, birds of prey person. A kite or a buzzard or something.
A buzzard person.
And
I
I should say one thing more about Joe, because Mike and I, we were old sort of Ericsson people, and Joe came from outside. And if Mike and I and Robert and others had carried on, then the Erlang manual would have become an internal Ericsson report, like some other languages. And Joe's idea was, why not write a book and have Prentice Hall print it? And that was sort of stepping outside the box.
That's just answered a question I've always had. Whose idea was to write the book, right?
Was it mine? I've forgotten.
Yeah, I don't know.
So just to clarify, what is the book you're speaking of here? Which book?
The first Erlang book.
Yeah, we
yeah.
waited 14 years after the language
right,
was developed to
right.
write a book to describe how to use it.
Okay, Robert. Your name?
Robert. I'm Robert.
Robert. He's Robert.
Robert, yeah. Probably a dog person, but it doesn't really matter. If I was to have a dog, I'd be a dog person. If I was to have a cat, I'd be a cat person. I am it. I like implementing things and writing stuff. So that's really my past the whole thing for it. I like implementing things. And if it's a telecom system or something else, it's fine. I'm easy. And it was an interesting problem.
Jane.
My name's Jane Walerud. I joined Erlang Systems in order to sell Erlang to other companies just after the summer one year. And within 2 months, the use of Erlang within Ericsson was banned, and that made it rather difficult to sell it outside the company. There was a man in the CS lab named Håkan Milroth, who's not sitting here, who persuaded me that there is something called open source. We really ought to make it open source. And he gave me some stuff to read, and I said, hey, that's a good idea. So I persuaded Ericsson's management to do that. And then I was one of the 12 founders of Bluetail. I think the only real business person of the 12 founders of Bluetail. I said something earlier today which it turned out people didn't know. I was at a dinner with a woman called Sarah Mazur, who is chief of research at Ericsson. Really very impressive person. And she took me to one side and said, I want you to know that I think that making Ericsson open source was probably a mistake because it could have been Ericsson's major competitive advantage. Okay, this is the head of research at Ericsson. As far as I know, she's still the head of research at Ericsson. I don't, these things change, but I think so, and it's not that long ago. So I want you to also know that there is a high-level support for Erlang within Ericsson. Okay.
Cat or dog or?
Oh, excuse me. Yeah, I have 2 dogs. They run my life. They're bird dogs, and life has changed a lot since we got them.
Excellent. So, getting into this, so I want to structure this roughly chronologically, and I've read a few times now Joe's history and Bjarne's history, and there's a lot of detail there, but there's a lot of backstory that I'd like to explore. And one of those is what the ingredients that went into the computer science laboratory, both technically and then within the team. So I want to ask this as sort of as a two-sided question. I want to go all the way back to the AKE. I want to just the lessons that were learned from that experience, which then fed into the AXE and Plex, and then you came along, formed the lab to look at solving problems that had sort of accumulated, but you also accumulated a lot of internal DNA, sort of collective wisdom about how to do these things. So I'd like just to give an open forum to talk about those things, both technically and then what you would have brought to that equation. So this is kind of open-ended to start things with. Joe, would you like to start with that?
No.
No.
Because I don't know anything about the AKE, Mike or Bjarne has to talk about the AKE.
So Mike and Bjarne, can you?
Well, the AKE was the pre-runner to AXE. It was a system before one realized that computers are very expensive. And it was a system, a distributed system programmed in assembly language with a number of processors running on number of memory units which are separate from the processors, accessing them along a bus. And it had a lot of advantages, that it was one of the first, what we call SPC, which was stored program controlled systems. It had a lot of disadvantages. One of them, it was horrendously difficult to program because everything was done in assembly language and a lot of pointer errors and this sort of thing. Along came a guy, and when they decided to make a new system, because they could make, it simply didn't have enough capacity to make local exchanges, they decided to make a system called AXE. I could spend a long time telling what these abbreviations stand for, but could you ask me later if you want to know. Now, the AXE was really designed by a guy whose name is largely forgotten, called Göran Hemdahl. Göran was brilliant. He designed the hardware, he designed the software, he designed the programming language, he did the bloody lot. And without Göran Hemdahl, I think I could reasonably say that Ericsson wouldn't exist today. He realized that he had to have a large number of processors, he called them regional processors, and he made a central processor to coordinate all these things, and he designed a language called Plex, together with another guy called Oleg de Bakhtin, who wrote the first Plex compiler in Fortran. It was brilliant architecture because he was the only person I know that actually did what would you call memory management in hardware. All memory management was done in hardware, and you could relocate data. You could buy changing pointers in a separate hardware control unit. It was called a control memory. Bjarne probably can tell you more about that than I can. That he could actually do everything which Erlang could do today about producing code, changing code on the fly. Now it was very good, and it made a lot of money. The time that Joe was talking about, that Ericsson had, or Bjarne was talking about, we found the computer science lab, because Ericsson had excess of money at that time, was simply because we'd won a very large contract with Saudi Arabia. And there was a lot of money over from Saudi Arabia. The Saudis, as well known, are usually quite well off. They have this thing called oil. The only problem with the AXE as Lime developed is, firstly, it was very difficult to program as well. Plex was a sort of real-time basic language. There were efforts to try and make it better, but the general metric which was used in Ericsson at the time is that a Plex programmer produced two lines of Plex code per hour, which, when you think about coding and this sort of thing, wasn't very, very good. It solved the problems of the AKE, and there was no pointer errors because the hardware memory unit could get rid of the pointer errors. All pointers were done through one degree of indirection. It also had another problem which turned up later, and I can explain why, but it's not time to do that now, that you could not duplicate the central processor. And the central processor was a separate Ericsson hardware design processor with Ericsson designed circuits. Initially, discrete logic circuits. They finally became ASIC circuits, and it cost more and more and more to keep the central processor going. So that you couldn't duplicate it. The Plex, as such, made it impossible to distribute to different processors. So the challenge was that, firstly, when we would sort of start this, when we started Computer Science Lab, was find a way to program more effectively, trying to get it a bit more than sort of 2 lines of code per programmer per hour, to get it at least to 3 or something like that, but hopefully a bit more. The second challenge was that could we get rid of this sort of specially designed processor and use it on a network of processors instead? And so productivity and distribution were the thing. Otherwise, the other characteristics which the AXE already had, no pointer errors, no memory management, and all the rest of it, that was our starting point. I think that's the sort of basically. Bjarne, have you got anything to add on that? You were there too, at the same time too.
Well, I think a lot of you have heard of a programming language called Ada. Well, that was part of quite a big tradition of concurrent languages. They were called Ada, they were called Chill. We had a language that I helped create, which we called Eric Pascal. And what all of these languages had, they had modules, and they had processes, and they had process communication. And sometimes they had very complicated process communication, like in Ada, they had something called rendezvous, etc. And
no.
well,
You don't want to go there.
but Eric Pascal was quite usefully used for some projects. And then at one point, I went to a 2-week summer course to Uppsala University and learned Lisp. Took at least 1 week to understand it. And I've never been the same since. I mean, once you move to sort of symbolic programming, I mean, you can't go back. And we were actually using Lisp for some support systems, which were actually interpreters, etc., which are actually symbolic. It's not mathematics, it's symbolic. So there we had some idea, to go the functional or symbolic way might be one way to improve programmer productivity. So we had sort of various threads and ideas before, and then we carried out the SPOTS experiments. Mike, you gave a presentation of that at the SETS conference in Southampton years and years ago.
And the first one was actually in Eindhoven.
But we managed to get DEC VAX to the lab, and we had a switch which Per Hedeland somehow got connected to the VAX. And there we had a laboratory environment to experiment with programming technologies for switches. So we wrote rule-based systems, and we had logic, we had an early ADA, we had all sorts of things to experiment with. And that was a sort of ground. And the silly result of those experiments was that we could actually write telephony in sort of all kinds of languages. So we were a little bit confused, but we had drawn some conclusions, and then we were ready to take the next step, and then entered Joe to sort of combine with our previous experiments, and
So
somehow
there's a terrific quote here. Joe, in your paper, you mentioned you went to Bjarne and said, hey boss, what should I do? And reportedly he says, you need to solve Ericsson's software problem.
Yeah.
And I wanted to ask about that. I'm not sure if that's a wink-wink or if that's a, no, seriously, you've got to solve this problem. Or what were you really asking him to do there, Bjarne? What was your thinking? That's a pretty big order, especially for somebody on it just coming. Well, you were a physicist, and I think you were doing rockets or something. Just that was your last gig.
No, I'd been working for the Swedish Space Corporation doing an operating system for
I just translate that into rockets.
Sweden's first satellite.
Joe is doing rockets.
Yeah.
Okay.
Well, I had done rockets before that, actually.
Okay.
So I was doing
Not
satellites.
Far off.
And,
So what were you asking of him there?
we always said that Erlang is rocket science. Yes. No, but it was just something about that I told him. I mean, that the lab had two jobs to do. One was create a software technology for future systems, and the second was help introduce new technologies in present activities. So we were doing graphics, interfaces, and we're doing using expert systems technologies. We got one of the first workstations ever in Sweden, etc. So we're doing all sorts of other things. So this was, yes, create a new technology for future systems. So
this is the ask,
Yeah.
and the work continues. At what point did it dawn on you that he might actually be, or the team might actually be delivering on this rather tall order? When did that happen? When did you look at that work and say, wait, this actually might be something here?
well, the thing is, to be a boss of a person like Joe might be rather sort of tricky.
It's very easy. I just do everything you say, Bjarne.
But the thing is that Joe is quite a friendly, kind sort of person. So to sort of keep control of Joe is you have to go a sort of roundabout way. And that was that we were working together with a user team who were creating a prototype of a new type for a new switch. And they needed a language to do this. So that's how we work. So essentially, I told Joe, help those people with the best technology you can. And then this was combined with all the sort of 15 years of experience that Mike brought along it.
Yeah, because when I came in, these guys knew all about telephony, and I didn't know anything about telephony. So
We could make a telephone call.
yeah, that's about it.
That's-
And
that's-
so
Making
our
the
way,
phone
and Robert,
ring,
our way of learning telephony was, Per Hedeland had built this exchange, and we just programmed it in every language we could think of. And that was learning telephony for me. And then these people said, well, that's all wrong, and it should work like this. And I started messing around with Smalltalk and built a Smalltalk model of telephony. And we used Smalltalk on a Sun workstation. It was very slow. And when it was garbage collecting, I went and had a cup of coffee, because it literally was time to have a coffee, 20 minutes or so. And we ordered a Tektronix Smalltalk machine. It was very expensive. I persuaded Bjarne to buy a Tektronix Smalltalk machine. And there was a long delivery. And while I was waiting for the delivery, I was describing, there's a guy called Roger Scargaval, and I was explaining to him how I thought you could describe telephony. And he said, that's the Prolog program. And he took me into his office and he showed me how Prolog worked. And I went, wow, Prolog, it's utterly fantastic. I love Prolog. So I wrote this telephony thing in Prolog, and we started running it on the machine. And the Tektronix machine came along, and Bjarne had managed to get us to buy this thing. It was fearfully expensive. And it was the first one in Sweden. And by that time, I wasn't interested in Smalltalk anymore. and I hadn't actually unpacked it. And it sat on my desk, and then Bjarne said, well, you're going to use the Smalltalk. We paid a lot for this. And the Tektronix salesman kept phoning me up and saying, how do you like the Smalltalk machine? Oh, it's great. It's fantastic. Yeah, are you having any problems with it? No, I said, no problems at all. Well, I hadn't unpacked it, so there weren't any problems. And then he said, could I bring some customers to look at it and talk to you about your experiences with it? And I said, well, I'm very busy at the moment, so... And then there was a guy down the corridor who wanted a Smalltalk machine. And he was doing Objectory, you remember, for being very Oxford. And he built an object-oriented design method in Smalltalk. So I accidentally sort of lent him the machine that became an object-oriented design method, which I didn't like that much afterwards. But it got him off my back. So it did do some good. And then the Prolog story started. And that led to Erlang, and Robert got involved.
So you got hooked on Prolog, but Prolog wasn't concurrent. It wasn't a concurrent language,
no.
and this was the
Well,
problem.
that's why it needed to be changed.
You had to dig into this thing. So I want to
ask
I want to ask you about your abstract machine. This is called Joe's Abstract Machine, the Jam. And I want to read to you a quote from Chuck Moore, the creator of Forth. He says that compilers are probably the worst code ever written. They're written by someone who's never written a compiler before and will never do so again. And when I read that, I made a connection to the Jam, because as it's accounted, you had to do quite a bit of research, and I got the impression from the account that you hadn't ever written, that this was sort of new uncharted territory.
Yeah.
And as it turns out, there's still a great deal of design that was the original Jam that still lives today. Is this a fair statement, or has it been completely?
Robert actually did all the groundwork, because Robert had collected a large number of papers about the implementation of Prolog and things like that, and he lent that to me, and I read every single paper in about a weekend. I read them very quickly. I didn't understand any of them.
And then there was a
and then
strand
suddenly
experiment.
I sort of thought, oh, that's how it works, and started writing a compiler.
Yeah, we'd done some work before on implementation. So I had this view, if we're going to introduce new technology into the company, say higher level language and so on, we should at least know how to implement them. Even if we don't do our implementation in products, we should know something about them. So I spent quite a bit of time implementing languages. I still do. But I did that, Robert. So I implemented Lisp. Well, partial implementation of Lisp. I did look at implementation Prolog. That's where I got all the papers from. There was also a vein then of doing concurrent logic languages. A number of concurrent logic languages. So I was looking at implementing concurrent logic languages. Two we were looking at, Parlog, one called Parlog and one called Strand, so we're looking at implementing them. And we actually did telecom systems in them. I mean, they could run in our lab, and they did everything. You know, multiple calls, and was concurrency, and so on. It worked, but there were still problems with the logic languages that didn't quite fit. And logical variables weren't very good for this. And a lot of other problems as well, too. So we migrated.
You could not do backtracking over hardware. If you started sending out the ring signal, you couldn't sort
that was very interesting. Yes, you can't backtrack over. If you set hardware, you can't backtrack over it. That happened with a colleague, Nabil El-Shiwi. He was doing a lot of work in concurrent logic, and in one of the systems he wrote, he'd forgot a cut. So if something happened, I think basically if you're talking to someone, the other person put the receiver down, your system would start backtracking, and you immediately come into a new call, right? Because it just didn't, which wasn't quite what it was supposed to do. So yeah, you had a lot of these problems using the logic languages. In some cases, they were just too powerful.
Can't unring a telephone.
Yeah, yes. What does it mean if you backtrack over a ring? So that's why cut logic stuff out. We cut out things like logical variables. We cut out backtracking. And then you sort of end up in...
Prolog without backtracking and without logical variables is a functional language.
It's a functional language, so suddenly we're in a functional language. That's why we ended up being functional.
By the way, Mike, didn't you do the first scheduler?
Yeah.
Yeah, I did the first. Joe designed the machine, and Joe started writing the virtual machine, the jam, in C, and I took one look at Joe's code and said, "Oh my God, we can't have that. That looks awful."
Well, I'd never written a C program before.
You'd never written a C program before, so I sort of started. So I did the first jam implementation, which I sort of gladly left over to someone
No, the
else.
first C one, because I did one in Prolog.
You did one in Prolog, yeah. And I sort of did the first jam application in C, which was actually used in the product, which in the thing that Björn was talking about, our users who were investigating a new system in Ericsson Business Communication, which was a unit in Bollmora outside Stockholm. And it actually was used and became a product called the Mobility Server. So the first Erlang-based product was actually the Mobility Server.
And you've lost the code.
And I've lost the code. At least I think I've got it on a 3M cassette. The trouble is I don't know how to read 3M cassettes nowadays.
So there's a tremendous amount of work that's been put into the virtual machine, the Beam technology, and it's evolved, and it's a fascinating read. I want to bring in a quote by a famous computer scientist, last name Virding. It's Virding's first rule of programming. Don't know if he's related to Robert. It goes like this: any sufficiently complicated concurrent program in another language contains an ad hoc, informally specified, bug-ridden, slow implementation of half of Erlang. Yeah, of course. Credit to Greenspun for the upstream source there, and that's that's clever and it's funny. But I know that there's a lot under that. So I want to ask this to everybody who's been through all of that. What is so hard about concurrency? What's so hard about doing it right? What's so hard about what you guys did?
Mike, do you remember the old PL163?
Oh, good Lord, yes.
Yes, but that was the first concurrent system we did.
I think one of the tricky things is getting. If you look at Erlang, it's got a send and a receive, and it's got a link, and it's got a small set of primitives from which you can construct all these other things. It took us a long time to figure out what that small set of primitives were. We tried lots of different combinations before we found. I mean, after the event, it looks simple, because it all fits together. But before you've done it, it's kind of tricky.
Well, I remember a meeting we had when we were discussing with these people in Bollmora what they wanted. We were trying to work out the concurrency primitives, and for that reason, at the time, we'd got hung up about pipes and Unix pipes. So we decided that all our processes should talk to each other through pipes. And we then had all sorts of problems, like sort of two processes decided to talk to a third process. We had a sort of muff pipe, join them together. And then we had another one that was going to talk to another called bend pipe.
Split pipe.
And I think that we were trying to work out how to do this. And then we had to we talked to our the people who we were supposed to support were looking at us getting more and more goggle-eyed and sort of say, we trust these people. We said, well, we sort of had a sort of quiet breakout session, and we said, let's think of some other way of doing it.
But it was actually the most complex part of the whole emulator at that time, the pipes.
It's something that sounds... I always thought pipe algebra sounded very simple because you'd have a pipe with ends A and B, and you'd just have an algebra connect A to processor X and split pipe A into B. And it turned out that when you moved a pipe, you had to send a tracer message all the way around to the end and it had to get back. And then you had simultaneous things had to happen. And I implemented all of that. And it was like 4,000 lines of Prolog, and I said, we can't do it that way. And now you see people write pipe systems on top of Erlang, like AMQP and things, and they in themselves are extremely complicated. So we just said, no, point-to-point communication with mailboxes is what should be in the primitives and not pipes. But it wasn't apparent because it just sounds easy, but it's not.
Yeah, I mean, that's one reason why, for example, there's nothing synchronous in the
Because
language.
it violates laws of physics.
Synchronous communication is difficult. If you
no,
really
it's impossible.
Well, difficult. Anyway.
It's possible.
Okay. Yeah. So
light doesn't travel infinitely fast. It's impossible.
That's why you don't want synchronous in the base. You want to keep things asynchronous. Then you can implement your level of synchronous on top of that. But once you start baking it in, it suddenly becomes complex.
Impossible.
Look, the problem is really from your background.
Very difficult.
We're both physicists.
No, but I mean, if your background is sequential programming and Fortran Common, I mean, you'll be stuck into these things like critical regions and rendezvous, etc. Whereas if your background is telecoms, even telecoms relay sets, here is this box, here's this box, here's this box, and they obviously all operate concurrently, and they send messages to each other.
But they travel at the same rate.
That is.
They don't travel
I mean,
instantaneously.
if that is your background, then sort of, well, that's an idea of cooperating state machines. That's a telecoms background.
I think also the problem is finding the right level of concurrency. So getting back to the concurrent logic languages, they were extremely concurrent. Basically, everything was concurrent. So you have a clause with a number of reductions on it. They were all done in parallel. So there you had to put a lot of work, effort into making things sequential. Because we're controlling hardware. Things had to be done in a specific order. You first had to do this, then do that, and do that. And if you're running things extremely parallel, then you had to put effort into making them sequential. So the problem is finding the right level. I mean, that's why we ended up with having lightweight processes, but within each process, everything is sequential, because that was a suitable level for doing things. You could sequentialize things very easily. You could see the order things were being done, and you had the concurrency there, because you had lots of them. But it's just finding the right level of doing things, right?
And this was through laborious experimentation.
Yeah.
It sounds like.
Yeah.
You didn't draw it up and just do it.
Yeah, because Bjorn mentioned Strand. So Strand is a concurrent logic language. Again, it's extremely concurrent, and we experimented with that, and we actually wrote a chapter in the Strand book where we implemented Erlang as it existed then on top of Strand. And one of the problems we had was making sure things were done in order. And you get some really strange things. So if you wrote code that did A, B, C, then did an exit at the end, but you got the sequentialization wrong, it just crashed immediately because the exit fell straight in. So there we had to do a lot of effort to make it sequential, or get a level of sequential execution in it, which we needed for our problem. Because one of the things you found out when you're controlling the hardware, you had to do things in the right order, right? Otherwise the hardware got very confused and did nothing or crashed or something like this for it. That was one of the biggest problems I had with our spots experiments, setting the things in the right order.
But there's one fundamental thing about Erlang, which is, I think, actually comes from the thing that Bjarne was working with earlier, which was the language which was called Larry Pascal. And that is what we call selective message reception. And that is absolutely fundamental. Now, through a series of unfortunate accidents, I became a manager in Ericsson for quite a large number of years. And I managed, for a period of time, for about 10, 15, like less than that, I can't remember, for a number of years, I managed a unit which was developing the current 3G system using a horrible, disgusting, and I'll probably get sued for saying this, I must say, concept called Rose Real Time. That was the correct answer to that. And it is really disgusting. And the interesting thing is that it did have a sort of fundamental sort of concurrency concept. It did send messages and all the rest of it, but it did not have selective message reception. And this means at any time you have to be prepared to read any message. And if you think about the sort of message reception as a matrix of a number of states and a number of messages that come in. If you have selective message reception, you can actually reduce that matrix to a much, much smaller net. Because in every state, you just say, I will only receive the messages which are relevant to me now. Now, that actually came from a language Bjarne mentioned, Chill, which he incorporated in Larry Pascal. And that, I think, we've generalized that in Erlang by having pattern matching on message reception. And I think that is probably one of the fundamental things which makes, I believe the same mechanism has gone into Scala. I don't know Scala, but those of you who do probably don't know that. I mean, they talk about Erlang-based messaging or concurrency in Scala. Now, that actually is actually fundamental. because that makes systems at least a factor 2 easier to design, because you don't at every state have to receive every message.
I think it also indicates one thing. A lot of the things in Erlang, I hate to say this, we didn't invent it. We did not invent asynchronous message passing. Okay, I would have loved to claim that, but we didn't. We did not invent the idea of isolated processes. We did not invent pattern matching.
No, I think links is the only thing, and that was Mike's idea.
I think links is probably the only thing in Erlang that actually is we initiated. And so in that sense, one of the strengths of Erlang is how we put things together. And also, we managed to keep it simple, keep the basics simple. Now, whether that was any great philosophical design or just laziness, I don't know, right?
Look, Robert, remember that I invented the process concept. It was only that I discovered that a lot of other people had hit on the same idea.
Yeah.
Yes.
Yeah, yes, we did actors, but someone else had done it before, but we didn't know about it, right?
I invented email.
So I want to fast forward. So let's fast forward. So Erlang moves forward within Ericsson and shows great promise and great success. And there's an entity formed to sell it externally. And it's ready to unleash the world. So I want to ask you, Jane, about your experience. You're coming into this organization. A few months later, there's the ban, and now you are tasked with or asked to sort of promote the idea of open source in this. Can you go into a little bit more detail on how that went?
Right, so Erlang Systems, I believe, was 5 years old when I joined it.
Yeah, it was the smallest
you
and least successful company in Ericsson. I had the advantage of being its second CEO, which is why I didn't have a brilliant career at that stage in Ericsson.
So they've been running for 5 years and had 20 people or thereabouts, employed mostly doing consulting within Ericsson on Ericsson projects using Erlang. The purpose of the organization was to spread the use of Erlang both inside and outside of Ericsson, because one of the problems with Plex, although it was an excellent language, was that people didn't want to learn it because they would thought of it as a dead end in their career. So that it was hard to recruit good people to program Plex. And Ericsson wanted to make Erlang popular, and so therefore make it possible to have a career doing programming Erlang outside of Ericsson. This was not successful. And so about 2 months, I started work, I think, in July or August, just like that, and something like October, the ban came through.
Sorry, just to clarify, this is one unit, or one business unit within the radio.
Tiny little company that called Erlang Systems that was in Kista. The CS lab was a little bit south of Stockholm.
No, the ban came down from the
CTO.
radio. Oh, it was at the top. It was at the top.
The top.
Okay.
Yes.
Okay.
Absolutely,
So this is a
the
ban.
top.
This
This is a do not use Erlang in any new products within Ericsson. Just don't do it.
And then you had to go and sell it.
Mike, det var bara
Well, I was already told to go out and sell it, but it's pretty hard to sell something out from Ericsson as this greatest thing since sliced bread that Ericsson refuses to
You
use.
just have an asterisk there next to all the.
It just doesn't quite work that way. But strangely enough, I wasn't fired immediately, which nowadays I suppose I would be because they've got better control. There was a guy there named Jocke Greben, who was at the CS lab, who had picked up one of Joe's ideas for a startup and said, well, let's do this, a thing called Eddie. And he sent out an email with saying what he was planning to do to the gang, and I had time on my hands. And so answered, well, who's going to buy it and why, and who's the first one to buy it, and these sort of business-like questions. And Mike told me, no, you've got to work with Jocke, because you're the only one asking these kinds of questions. And I said, oh, right, okay, well, I guess. And so I got a part-time assignment at the CS lab helping Jocke with Magnus Törnqvist to do that. And when I was there, then the CS lab decided that I wasn't really all that bad, although I was female and business person and not a programmer and all that sort of thing.
The business person side was the worst.
It was bad. I remember the first time I went walking down the corridor. Anyway, then Håkan then told me, well, we've got to get it out, and we've got to get it out. We've got to get it out of Ericsson because it is this excellent, and the only way to do it is Ericsson. One good way to do it is open source, and taught me about it, and there you go.
So that seems very, very fortunate, because I mean, if that those conversations don't happen, and you don't participate in that, and Erlang isn't open source, Erlang becomes an internal, forever internal, and since it was banned, it would have been dead.
It would have been dead. And
so we wouldn't be sitting here.
No.
This is a critical
It was
moment.
critical. Without me there to do the persuading, I don't think it would have happened either. But I mean, once it was out, well, then we needed to do something else, which was basically a lot of the gang were reasonably upset with Ericsson management. We were planning murders, actually. I remember sitting on the sofa in Mike's office, planning different ways of murdering a guy. We'll learn how to dive, and then we'll swim out to his sailboat and put like one of these limpet bombs on it. No, he's still alive. As far as I know, he's still alive. It's okay. We were planning murder. So we decided to leave Ericsson, and people's IP was there, was available, was open sourced, and and I thought, right, fine. Well, do you guys realize how hard a startup is? We need a business idea first. And then they said, oh, not a problem. We want to meet at Joe's place on Saturday. We'll come up with some business ideas. And I said, yeah, sure. Yeah, all right. Okay. 41 business ideas. 41 business ideas.
Well, they were used to generating options and experimentation.
Well, they've been gathering them. They've been thinking about them, but they knew nobody who knew how to build a business. So, okay, there's Jane. Right, we're going to do this now. And then, oh God, 41 business. Okay, so how do we choose? That was the problem was at that point. Yeah, it was fun.
So,
I just want to say,
now you've been.
Just want to say one thing. Getting it open source was a real feat. I think, if I remember correctly, that's the first open source software Ericsson had.
Oh yeah, by far.
And now they still only have very little open source software. So getting it out was a real feat.
Just a moment ago, you said that somebody was reevaluating that decision. I mean, they could have just been, somebody wanted to keep it away from competition or any other.
Look, Erlang is really good, okay? All of you agree, because you're here. Erlang is really very good. And so either, as Bjarne said once upon a time, either a steady state, a reasonable state for using Erlang within Ericsson is that Ericsson can then make these huge, complicated software projects successful, and none of the competition can. Okay? Mm-hmm. Or you can let it out open source, and then lots of people, the more savvy people first, will use it, and that will then you'll be able to get people who make a career outside of Ericsson to use Erlang, but it won't be Ericsson's secret weapon. And those are the two steady states.
And Bell Labs had a lot to do with setting a standard with C and C+ to get technology out.
That wasn't important to
That
Ericsson.
wasn't important. No one cared about that.
No.
No one even. Okay. Because that sort of defined a model of knowledge sharing that could have gone. But Ericsson was.
That was, as far as I know, nobody knew about that at that time.
So I want you to. Which conversation? Oh. Mike knows if it's the conversation that happened or not. Oh. I'm not sure. Mike, you see that Mike knows something here. What?
No, I don't think so.
You signed him up.
Mike doesn't know anything. No.
I don't know.
I know nothing.
So let me just explore this, because I just heard somebody who, I mean, your bona fides in startup space are second to none. And you just said Erlang is great. It's really great. Now you believe that. You're not. This is so. What have you seen? Now I'm scared because we're used to always battling through a business case, a managerial case. At least there's a lot of stories of practitioners will use this as a tool to solve something, sort of an angle under a radar, and then it's difficult to sort of sell it upstream. And I know that's been a history of Erlang. What has been your experience in industry with this technology specifically along those lines? That dynamic of it's virtuous from a technical standpoint, but you face opposition from sort of managerial acceptance.
You see, I'm in a startup space. I don't deal with big managers anymore.
So you are, it's pure meritocracy.
So I can just sort of say, yeah, it's going to be Erlang, guys, and they say, fine.
But look, there's one very important thing that we tend to forget, and that's one of the success stories of Erlang. And that was about that period, just before the open source, etc. Erlang was being used in successively more and more products. And at that time, there was a transfer of Erlang from the research laboratory to a product unit run by Kenneth Lundin, who is here somewhere. And that is something that could have failed or could have caused all sorts of problems. But actually, somehow we managed to do that very well. And there was, for a while, a sort of overlap between the product people and the lab. But now, I mean, the true ownership of Erlang it lies in the hand of that group. And they have existed ever since, supporting both internal and external customers. And that is also one reason that people like Joe could sort of disappear. Because Erlang wasn't dependent on these three guys any longer.
Yeah. I mean, we absolutely couldn't have done what we did in Bluetail and all those other things if Kenneth and his gang hadn't been providing Erlang on the inside.
Oh no, the whole community, it was then a very small community, and people are interdependent, definitely. Yes. And I think that's what's one of the fun things now, is that we still are. I mean, I'm pretty much on the outside now, but still true that Klake and Johan Bevermeer spent 3 days at my house, and I left them in my house just yesterday evening. I mean, we're still friends. There's still this level of trust, which is great. Yeah?
Okay, we need to wrap up. I know we are running a little bit late. I'm going to ask. Can we have a little bit more time? Is that okay? You're fine with that? Oh, I'm not comfortable with the level of enthusiasm here. Can I get some more? Can we get some more time? Yes.
Garrett, we'll just lock the doors anyway.
Okay. Well, let me do this, because I think this segues into. I'm going to just loft up a big softball here for everyone to hit, and it's. I want to try to connect a few dots, because history is a big part of this story, and I think there's so much that we can learn by studying the history of this language. So unique, and the circumstances relative to other languages very, very, very unique. But I want to now fast forward to this moment. I'm going to name some companies here, and you may have heard of a few. IBM, Visa, Facebook, BT Mobile, Pivotal, WhatsApp, and there's a telecom startup called Ericsson. These are all companies that use Erlang in a product that is central to some business line.
You forgot Cisco. It's another one of those small startups.
Cisco, it's another startup I hear. They do networking of networking. Yeah. And the list goes on and on and on and on. And now I'm going to read 10 points that I think, if you look at the products in each of these companies, and I understand sort of what these do. I want to enumerate their feature set here. Number one, handling a very large number of concurrent activities. Number two, actions to be, you may recognize this, keep an ear out, you may recognize this list, and then you tell me what this list is. Number two, actions to be performed at a certain point in time or within a certain time, so soft real time. Number three, systems distributed over several computers. Number four, integration with hardware. Number five, very large software systems. Number six, complex functionality such as feature interaction. Number seven, continuous operation over several years. Number eight, software maintenance, reconfiguration, etc., without stopping the system. Number nine, stringent quality and reliability requirements. Number 10, fault tolerance both to hardware failures and to software errors. And looking at the products that are built, it seems to me that Erlang was selected specifically because of these rather phenomenal characteristics. What is that list?
Well, I cheat because I know, but...
I'm going to ask this.
That's Bjarne's list.
This is Bjarne's question.
Well, it's in my licentiate thesis, but a lot of it actually comes from Mike.
So these were all the requirements for the laboratory. This is before.
Yeah, I mean, when I joined, they'd already figured out that's what they've got to do.
Erlang. There was no.
This is the, I'd say the problem.
That's the problem. That's the problem.
That's the problem.
That's the problem.
If you're going to make, or we were going to make a system that would be useful for telecoms programming, they had to fulfill all those requirements. Otherwise, it just wasn't interesting.
Okay, are you ready for the question? Here we go. This is a super softball. You're going to love this. Okay. So after 30 years now looking at how Erlang is used inside Ericsson and outside, are you comfortable saying mission accomplished? Oh, that's hard. All right.
Look, I think so. At the same time as we were fully prepared that there could be better solutions to each one of those 10 items.
Absolutely not.
Okay, this is
no. I mean, that was the first good prototype. You know, WhatsApp's the first prototype of a big system. I mean, we're going into the future. We're kids. I mean, I view computer science as this little kids. We've invented all this stuff. I give these lectures. You know, the iPhone 6 is 250 times as powerful as a Cray 1. And what are we doing with it? Playing Pokemon Go? What are we fucking around with? Come on, we've got the edge power. You know, we're going to lose all of history if we're not careful. We've got millions of times more power in the edge network. Basically, in computing, the edge network, this is all the things that are connected to the internet, has got billions of times more power than the servers in the center. Right, and we'd never be able to use it with distributed computing, and we have to do it. And things like Erlang and a lot of other things are going to come into that. So we have to redo it all because it's totally fucked up.
Does this change the problem definition?
Sorry?
Does your observations there change or augment that problem definition, or can we go back to this list of 10 as a sacred document? And just
yes, yeah. I mean, that can be just taken and carved into words of stone, and then we've got to add another 10 things as well.
Yeah, the problem domain's correct and relevant, and I think that gets back to one reason why Erlang is interesting is because a lot of other things apart from telecoms have exactly the same set of problems.
Yes.
Otherwise, Erlang wouldn't be interesting. I mean, there are things, I hate to say it, but there are things Erlang does not do very well if it does it at all. Right? But for the problems of that domain, it is a solution to it. Perhaps we could do a better one today if we start all over.
Yeah, of course we could.
Trouble would be that is we have influence.
Trouble is a lot of work. We now know it's a lot of work to do that. We didn't know that then.
I would like to add an 11th requirement that you also need good programmers. If you have crap programmers, you get crap systems. And there's a theory today I've not read the paper. There's a paper saying the myth of the 10 times programmer. This is totally untrue, that some programmers and some software people, let's not call them programmers, let's call them software developers, because it's a lot more than programming. It's testing, it's working out high abstractions, there's a lot. So programming is just a minute part of it. Unless you have good software developers, you're not going to get anywhere. And a lot of people are an awful lot better at software development than other people. And just have to keep that in mind. That I used to say in Ericsson that I could do when I was a manager there, I could probably do the same. If I had 10 really good people, I could probably do the same thing as the 150 people I was managing at the time.
Oh, yeah.
That's actually what I would say is one of the things that I would like to add to that list, and that is that Erlang is, the step into Erlang is a bit too high. So that although you've all taken it, it's daunting, and so a lot of people don't take it. And if it were easier to learn, or that we somehow brought that step down, I don't know exactly how, that would be an extraordinary boost for the Erlang community.
Jane, I actually disagree with you. I think keeping it hard to learn is good because it gets
No, I think
it keeps the bad programmers out of it.
Sorry, I disagree with both of you. You see, I think the reason it's hard to learn is because they've taught programmers these brain-dead, stupid languages which teaches them to think incorrectly to start with. I mean, they've learnt Java and things like that.
Wasn't it Donald
and then you've got to unlearn all that stuff.
Wasn't it Donald Knuth that said that learning Fortran causes irreparable brain damage?
No,
But
That's what caused it. Thank you.
I agree with Joe here.
If Erlang was your first language, you wouldn't say that.
No.
It's because Java's your first language that you say that, or C, because you do think slightly differently.
Some of the concepts in it are just not what most people are used to doing. The concurrency and the message passing and so on. If you don't
if you're coming from a sequential background, that is really strange, right? And however you think about it, it's a rethink on how you design systems. You just can't get around that. If I write something in Fortran, if I write something in Erlang, the systems are going to look very different.
But as I always say, I mean, the world is parallel, right? And
Okay.
We're talking at the same time now.
we're all talking at the
we
same
are,
time. I
and
think this
the
is the
problem
natural
here
state of
is
affairs.
that not everybody learns the Erlang as the first language. They usually learn something else first.
Yeah,
Right?
well, that's the fault of the universities and things.
It's not the university. They're in second grade or first grade at the moment, and they're learning not Erlang, they're learning something else. Honest.
Okay, so no,
I think the problem is not Erlang per se, it's the principles that underlie it. I think that's where the problem is, really. Not the language itself. Most people can learn the language if they want to, or learn any language if they want to. It's grasping the basic ideas, and if those basic ideas are different from what you're used to, you're going to have problems. There's nothing strange. I mean, I had trouble the first time when I was learning Lisp. That's way back. My initial problem with Lisp, funnily enough, was the parentheses, but I was thinking of parentheses as something that brackets stuff, right? Not as defining structures. So I could not see, why can't I write a function name and put that in a Lisp, because it's in a parentheses, because it's just a bracket. And of course it isn't. And that's what, it's just a different concept. And that's what did. And I think it's the same thing with Erlang, or the type of language Erlang is. There are a lot of concepts, there are a number of concepts there which people are not used to, and they're the ones that cause problems.
You know, but there's something else about Erlang that people forget, that even bad programmers quite often get Erlang programs to work, which is a real disadvantage. if they'd stuck to C++, they'd never get anything to work. So
I can say one thing also, getting back to what Joe was talking about. I think one of the reasons we could develop Erlang is we had time.
Yeah.
This wasn't sort of a 3-month project. It must have taken 4 or 5 years from when we started until we were happy with the basic ideas behind it. And we still hadn't worked out the proper syntax anyway, but we just worked out what are the basic ideas you need. Yes, you need this concept of processes, concurrency, the sequential natures in the processes, the function was nice, the linking and so on for doing error handling. Just working out these basic ideas took a long time. And one reason we could do that is we had contact with these people in Baltimore who could come back and say, yeah, this is a fantastic idea, but we can't use it. Or what occasionally happened, this was a really bad idea, like the pipes, for example. And so they say, yes, this is a good idea, we can use this, this works for us. Just getting this feedback for them, it took time, and we could do that. And if you have something realistic, say you've got 6 months to develop a new language to build these type of systems, you're not going to get anywhere, right? Not with a new one anyway.
Okay, we've got to wrap up. We're out of time, but I want to give each of you an opportunity to close. And I sort of prepped you a little bit with an email ahead of time. And this is the question that I'd like you to answer. There's a student out there who's taking computer science very seriously and wants to learn, wants to be excellent. I'd ask each of you, as succinctly as you can, to give that individual sort of the most pithy advice that occurs to you. What advice would you give that individual embarking on a career, starting with study and entering a workplace? That individual, what advice would you give him or her?
Well, I'll just restrict that question to computer languages and not to sort of knowledge of operating systems, databases, and everything else, because I would say the important thing is to learn several languages, not just Erlang, not just start and what's more, make sure you actually learn assembly language. Assembly language is very important. Assembly language is seldom taught, because unless you actually understand what is actually ticking away at the bottom of the machine, you'll never be able to understand what's optimal and what's not optimal. Learn lots of programming paradigms. Learn Lisp, learn Prolog, learn functional languages. Learn a lot of things so you can actually understand the various different paradigms. Don't just stick to do what they seem to do in universities today. They teach people Java and that's about it. That's horrible. Make sure you actually learn. Prolog, for example, is very, very intuitive to learn because it's a totally different programming paradigm from everything else. So very important not just to sort of be single track, do a lot of things. It doesn't matter if you don't do a lot of things completely, learn them to the end, just know enough about them so you appreciate there are other ways of doing things.
Sure.
it depends what sort of programming you want to do, but if you want to do scientific programming or technical programming, I think a good grounding in maths and physics is, although you're not majoring in it, I think, don't neglect the maths and don't neglect the physics and English, learn to write and things like that and to communicate with people. I think that's just as important as learning to be good at programming. And do it a lot, do a lot of programming.
Okay. Bjorn.
Well, I agree very much with what Mike says. I mean, programming language technology is like a lot of concepts, abstractions, so that each programming language is like you sort of take a subset of that and you take another subset. I mean, process, what does a process look like here? What's it called? Oh, here it's called task, or here it's called, but it's the same. I mean, it's a concept. And then also, like Joe says, about maths. I mean, early on when there was no computer science education, a lot of the best programmers were people who had done sort of technical physics, because they were used to dealing with abstractions. And I felt very much when I was doing programming that it was like doing sort of tricky maths. I mean, you had hit on the idea, how do I solve this? And people are more or less good at that, and you can sort of train your abilities, and you can sort of study how others have done it. And I remember when I was a manager, people who got stuck on something, and they were using all sort of tricky facilities in PL1, etc. And I started looking at the problem, and I realized, yes, that chap, he had not managed to solve the problem. I mean, it was like a maths problem. He hadn't hit on the solution. And the solution is an algorithm. And, well, you have to do maths, etc., and you have to study lots of languages just to train your mind to doing that sort of thing.
Robert.
I'll go both. I agree with Mike here. Learning multiple languages, and they're different languages. I mean, if you learn 3 languages and all basically the same, that's really not going to give you very much. You need to learn languages that are different. Yeah, pick Java. I don't know, I can't recommend it, but pick Java. Pick a functional language, pick a logic language, pick a concurrent language. They're all different. So you get a feel for the different concepts. You also give you a better feel of for the problem, what is the correct language? I mean, I don't think there's any language that's good for everything. You can program anything in any language, but whether it's good for it's another issue. And yeah, it's all about problem solving. Now, I'm lousy at maths, to be honest. I've fortunately forgotten all my physics as well. But it's all about problem solving. Whether you're developing a system or developing a language, it's solving a problem. That's what we were doing. We had the problem, the 10 points basically, and we're solving the problem for this. So it's all about problem solving. And I don't know if you can practice problem solving, but
yes, you can.
Yeah, sure.
That's what maths
you
is.
solve problems.
Okay.
But when I studied maths at
problem.
university, I got books of sort of old exams. And my fellow students, they would sort of solve one problem here, one problem there. I would solve the whole book. And that was just practice. You know, to get my mind working.
Much more diligent than I was. But anyway, it's the problem solving. That's what it's all about. Whatever you're doing for it, it's the problem solving. If you don't like problem solving, tough, right? You'll never make a good programmer.
Okay, I'd like to add something as well. And I would say that a lot of the problems even a good programmer is going to face in life are how to influence people, how to get what you want done, okay? And that is also possible to practice and to learn in university. You go into the university societies and you join them. And you build the bloody float, and you wear the funny costume, and you go to the parties, and you try to figure out how people work, okay? And there are lots of books around that will help you, okay? But I think that's really important, because I think that the people who I know who are unhappy in their 40s are the ones who didn't learn enough of that skill. They might have wonderful technical skills, but if you don't know how to get your will through, if you don't know how to make an argument, persuade people, get something done that needs to be done, that needs other people to accept it, then you will probably not be as effective and happy in your life as you want to be. So I would think that's pretty important.
I remember very well a meeting with managers and people, etc., where Jane presented the idea of open source. And I remember very well that you did not say one single word or mention anything that I did not know. The thing was just that you could sort of get it into the heads of those other people, which I couldn't.
Yeah. So this is a skill one can learn. It's like another programming language.
Jane, I'd like to thank you for one thing. You recommended a book to me once called Influence by Cardelli.
Cialdini.
I've read that book, and I have that book in my bookcase, and I read it once a month.
It's absolutely fantastic.
And you
Okay,
always...
Robert Cialdini. It's old now. It's still wonderful. Influence.
And I have to thank you, Jane, for something. I mean, when I was younger, I thought the way to deal with technical problems was to sort of out-argue people technically. And then Jane came along and very patiently explained to me, and you said to me time and time again, you said the relationship comes first. And I think you will probably remember that I disagreed with you. And then I began to notice that you were right and I was wrong. So I'd like to thank you for teaching me that.
So,
I can just say that's a problem we had in the lab. We were technical people. So our view was if we present a better technical solution, people will adopt it. And we were wrong.
We need to wrap up. Let me just say this has been a dream come true for me. I appreciate this. It's been very special, I think, for everybody here. We've gotten so much out of this. I'd love to do this more often. But for now, thank you so much. Ladies and gentlemen, please give a round of applause to the founders of Erlang.